Hi, and welcome to today's lesson on quadratic graphs. This is lesson 8 in my GCSE preparation course series, designed to help those in year 10 prepare better for year 11 next year, especially in the current situation where you've been missing real lessons. So we're going to continue with our work on quadratic graphs today, and we're going to pull together everything we've been doing with quadratics and tackle some of the slightly different questions that can arise talking about quadratic graphs. While we wait for a few more people to log in, have a go at these tables of values. So you've been given equations and you've got to find the corresponding y values. This would be in readiness of plotting a curve. If you've got time, then have a go at plotting or sketching the graphs for me. Alright, we're just going to have a few minutes on this. Welcome to those who are just joining. We're just filling in these tables of values as a starter to prepare for the lesson. As a reminder, you can download the handouts in advance of the lesson from my website, mrsk'slightbulbmoments.wordpress.com. So you can have a go at these in your own time. And also there's further questions on that we don't get time to do all of, and you might want to have a little bit more practice. So that's all on my website in advance of each lesson. Right, if you want to finish the bit you're doing. Now if you're just drawing a graph, you can finish while I'm just talking through this next bit, because I did want to mention that if you've got a, I can't remember what the name is, but more of a scientific calculator, the sort of cross between a graphical calculator and the normal ones, then you can complete these tables of values on your calculator. So for example, I've got the Casio Class Whiz, which is one of the easier options, I think, the more user-friendly options, but still at a cheap price that does a lot of the content for you. And you're allowed those in the calculator papers. So you can just click, if you go onto your menu setting, number 9 says table. So you click number 9 and then it says f of x equals, and you just type in your equation. So for question A here, I'd type in x squared minus x minus 6. You then press equals and it gives you an option to type in a g of x. That's just a second function. You could type in, for example here, b as well, and it does it all in one go for you. Then you type in your x values, so the fact they start from minus 3, they end at 4, and they go up by 1 each time, so the step is 1. You press equals again and it would just read you out the whole table of all those values you need to fill in, and it would have one column for a, your first function, and one column for b, your second function. So if you've got one of those calculators, it's handy to know that it's quite time saving for something like this. If not, then you do have to do it by hand, it's not a problem, but just be careful with your substitution. I'm going to put the answers up now. All the answers are coming up together, so you've got the answers for table A, for table B, and their graphs. So the extension was to plot or sketch the graphs, and those are the graphs with turning points and intercepts marked on. So have a little check of what you've got against them. Now hopefully you can spot in your tables that we've got this symmetry. If you look in table A, the y values go 6, 0, minus 4, minus 6, minus 6, minus 4, 0, 6. And if you look at the top curve there, that's y. We're sort of going down one side of the curve as we go from x is minus 3, minus 2, minus 1, 0. So the y-intercept there is at minus 6. It then goes down to the turning point, and then back up through minus 6, through minus 4, 0, and up to 6 again. So all quadratic graphs will have some sort of symmetry to their tables. So it's a good way to check if you think you've made a mistake somewhere. You should be expecting to see a symmetrical pattern. In B, you actually see the turning point as well. So we've got -5, 0, 3, 4, 3, 0, -5. So that 4 is where it turns. In the previous one, we didn't see it. We just knew the turning point was below -6. Because we had -6, then nothing, then -6. All right. So well done on that. Just a hint, if you're doing the second one and you've got things wrong or you've made mistakes, it might be... Sorry, just go back there. It might be a calculator error if you did it on calculator, for example, with your negative. Whenever you're putting negatives into your calculator, put them in brackets. So I'll just show you one substitution here. Let's do -2 as x. So we've got minus and then -2 squared plus 2 times -2 plus 3. So that is how I would type it into my calculator. Whenever you're substituting negatives, put each negative in a bracket. It just depends. Some of the models of calculators get a bit funny with it, but this way it's sort of a foolproof way to not make negative errors. All right, well done. Let's get going then. So we're going to look first at some plotting graphs, so just what we've been doing there with the substitution, but the application of it as well. So just have a little read of what we need to do first in this question and have a look at the equation. Okay, so we've got a slightly more challenging equation here. We've got y equals x squared over 90 minus 2x over 3 plus 20. This could very well be on a non-calculator paper. I don't think it would be with these numbers because in a minute you'll see we get decimal places in them. But this type of question could be, so you would have to substitute it. If not, and you've got one of those calculators like I said, you can just plug these values in and you get these numbers: 20, 14.4, 11.1, 10, 11.1, 14.4 and 20. Okay, so that's your substitution. Now you have to plot those points. Be really careful with your scale in questions like this. Make sure you've got your scale correct. So if we see here, every big square is 10, and that's the same on the x and the y. If you plot your points, it would look something like that. Here is another way you can check with your quadratics. You're expecting that parabola shape. You're expecting a nice symmetrical curve. So if you've got one that's lying completely out on its own, you know you've done something wrong. So you can go back and check your table. Okay. Now it needs to be joined up with a smooth curve. If you just put these crosses, you would not get the mark. So whenever you're asked to plot a curve or plot a function, it has to be joined up. I'm going to try and do this on here, but it won't be very neat, but obviously it'll be a bit easier in pencil for you. When you're doing a curve, let me just draw this one up like this. Well, that could have been worse. When you're drawing a curve, make sure it's one smooth line. It can't be feathering, which is what we call when it looks a bit like this, and you do lots of little lines to try and get a nice curve. Can't do that in maths, has to be one. It can't be straight, jaggedy edges. The other one a lot of people do is they do a curve and then they get a flat bottom and then a curve again. So try not to get that flat bottom. Nice curve. Okay, once we've done that, it then asks you one applied question about this. And it says, how far above the creek is the lowest point of the bridge? So you might be able to just see it from the graph there, but always check back at the question, check which value is which. So if we look back, x is the horizontal distance in meters across the bridge. So that's as you go along the x-axis, is sort of as you're walking along the bridge. Y is the vertical distance in meters above the creek. So y is the height above the creek. Now it says how far above the creek is the lowest point of the bridge. The lowest point is that point here, the turning point, and that is 10 meters above the creek. Okay, it's quite a nice applied question there, but some people do find it tricky when they start to be about real life situations and trying to interpret the graphs. It's often talking about the minimum point, the maximum point, or a y-intercept. So that's a few little hints for those. Let's try one more of these. Now this one, I'd like you to try doing the table of values first before I give them to you. So either typing them into your calculator or doing them by hand. Just try 3 of them, but I want to check we're getting our negatives correct there. Right, off you go. Alright, should we have a look what we've got? So these are the values we should have in our table there. 0, 18, 32, 42, 48, 50, 48, 42, 32, 18, 0. Again, spot that symmetry in what we're expecting to happen. Now we need to plot them on our graph. I'm going to give you the scale there. I'm going to extend it on because it's a bit easier to read off once we do it. And those are our points. Again, we've got to join them up with a smooth curve. I'll try my best here. Okay, something like that. And that shows the path of the ball. Again, 0, 0 is where the ball started, and you can see it nice and clearly. It would arc through the air and then come back down again. So our first question is, use the graph to find the maximum height the ball reached. Hopefully we can see that y was the height there, and you can always look back at the question. So the highest point it reached was 50, right up in the middle there. That was this point, 50. The ball's path was over a lake, the far bank being 80 metres from the golfer. Did the ball clear the lake? So we've got a lake 80 metres away, or kind of until 80 metres away. So imagine the golfer is stood here at 0, 0, because that's where the ball starts. The lake goes for 80 metres, it goes all the way up until here, and then stops. Then there's the far bank of the lake. Okay, so we've got water between those 2 points, and we've got banks either side. So did the ball clear the lake? Yes, it was still in the air at the end of the lake, and it only hit the ground 20 metres after the beginning of the bank. Okay, so yes, it did clear the lake. Hope we're all happy with that one. Just reread the question if you need to work out what the height was, what the distance was. Draw a little diagram like that. Draw the lake in if that helps you. Okay, super. Now we're going to move on to the little bit that a lot of people find tricky with these graphs. So even if you found the earlier bit easy, this might be a bit more challenging. And it's using graphs to solve equations. We are very used to doing question A here, 1A. B, C and D are much less familiar. So let's have a look. We've been given the graph of y equals x squared plus 4x minus 5. Now we've got to use that to solve x squared plus 4x minus 5 equals 0. Now that's like having 2 functions. Firstly, without me telling you anything, you know if it equals 0, you could factorise it, solve it, you get the roots, and they're your solutions. So looking at our graph, our roots are 1 over here and minus 5. Okay, so we know straight away those are our roots. But I want to show you why. That's because we've got 2 functions. So if you look at the left-hand side of the equation, we've got x squared plus 4x minus 5. And the right side of the function, we've got y equals 0. Now because they're equal to each other, it's like saying they cross. So can you see I've added in an orange line? That's the function y equals 0. Because everywhere along that line, y equals 0. The one on the left-hand side, y equals x squared plus 4x minus 5, was the curve we had in red. So where they cross is where they are equal, and those are our solutions. So I would write down x equals 1 and x equals minus 5. I think that's what it was from the graph. Let me zoom out. Yeah. Okay, we don't need a y solution in this. It's not a simultaneous equation. If you look at the equation we've been asked to solve, this one, it's just got x's in it. So we just need an x solution. All right, now that's hopefully going to help us in the next question. Have a look at it and see what's different about question B. All right, have we spotted it? We've still got x squared plus 4x minus 5 on the left, but this time we've got equals 4. So our two equations are y equals x squared plus 4x minus 5, which we've got drawn, and y equals 4. So let's draw in the line y equals 4. And can you see that's the orange line going through 4 on the y-axis? So now we've got x squared plus 4x minus 5 equals 4. Where they are equal is where they cross, where they intercept. So if we try and read off our graph, we've got about minus 5.6, I would say. And in the positive, 1.6. So those would be our two solutions for that one. Okay, can you see if you can work out what to do with C? Yeah, we've got our two sides. The right hand side this time is minus 6. So we just draw a line across at y equals minus 6 and we try and write down our solutions. So our intercepts of those two functions. So reading off of our curve, I think we get minus 3.75. And in the positive direction, we get minus 0.25. Right, let's make it slightly more challenging. What about the last one? Can you work out what extra line we need to draw in? Yeah, let's have a look. Our left-hand side is exactly the same. The right-hand side is now y equals x. Now we know the line y equals x. Have a look at how I've drawn it. Now, can you tell me why I haven't just gone diagonally across every square? Because you might have been expecting a line slightly more like this. That's how we normally draw y equals x. Why is it not that? Can you spot it? It's because y equals x means your y coordinate and your x coordinate are the same. So here, this point that I've just crossed in blue is 1 on the x-axis and 1 on the y-axis. This point is 2, 2. 2 on the x, 2 on the y. This point down here, minus 3. Here, minus 6. So this line is where y equals x, and that's because my scale is different. We've got each square being 1 on the y-axis and each square being 0.5 on the x-axis. So just be really careful, don't go straight for a normal diagonal across the squares. Check your scale. So now we've got that, we can work out our two solutions. Let's just scribble out my crosses. Can we work out where it intercepts? We've got a positive solution of x equals, what do we think, 1.2? And then a negative solution of minus 4.2. Okay, I hope that's helped with kind of solving from a graph. You'll notice the thing that's the same in all of those questions was the left-hand side of that equation. We always had x squared plus 4x minus 5, which was the equation we were given, and that red one that was drawn. So that's what we always need the left-hand side to be, is the same as our equation. And then you can just draw another line across it and work out where they intercept. Let's look at a few now then that don't have that same equation. So, top one, have a look first. The left-hand side is the same, but the right-hand side's a bit tricky. Just have a little look at question A and see if you'd work out what to do. So the left-hand side is the same. We've got 2x squared plus 5x minus 3, which is what I had in the original equation. So that's my curve, lovely. My right-hand side is 2x plus 1. So my two equations are y equals 2x squared plus 5x minus 3 and y equals 2x plus 1. So I've got to draw the line of y equals 2x plus 1. Now this table should help us for that. So either you can do that by knowing that 2x means a gradient of 2 and 1 is the y-intercept. So you could start at 1 and just go along 1 up 2, along 1 up 2. Just be really careful of scale. But I think it's a bit easier just to choose 3 points. Always choose 3 points, not 2. Because 2, if you've made a mistake, you'll never know. With 3, if they don't form a line, then you've made a mistake. So it's a really good check. So if we fill in these coordinates together, we're just doing the 2x plus 1. So 2 lots of minus 2 is minus 4, plus 1 is minus 3. So we're just doing this equation here. If y equals 2x plus 1 and x is 0, 2 lots of 0 is 0, plus 1 is 1. 2 lots of 2 is 4, plus 1 is 5. So these are the values I should get. And if you plot them, you'll see they've just come up as crosses on the graph there. And join them up with a nice straight line. We've got our straight line on the right-hand side. We've got our curve on the left-hand side. We work out where they cross, and we write down our solution. So this time round, we have got a positive value of 0.8, let's say. And a negative value there of minus 2.4. I'm being quite rough there with this. Our scale, these squares are quite big, so it's quite vague with where you are. Try and be as accurate as you can, especially if you're given a better scale or a better axis. So I'm going to get rid of that line and those crosses. Have a look at question B. You'll see here the left-hand side is different. Can you work out what to do to make it the same as the one we've got drawn in the question? Yeah, so we've got 2x squared plus 5x. We want 2x squared plus 5x minus 3. So we've got to take away 3 from both sides. Now, if I take away 3 from the left-hand side, it now looks exactly like the equation I want. Perfect. You've also got to remember to take away 3 from the right-hand side. So do you see we've now, rather than 5, we've now got 2. Now you can separate it out into your two functions. The left-hand side is the curve we've got drawn. The right-hand side is just the line y equals 2. So we can draw that on, and we can then work out our intercepts. Where does it cross the curve? So we've got a positive value of 0.75 and a negative value of minus 3.25. Okay with that one? So we had to edit it slightly to make it match the one we've got drawn. And that's because that's the curve you've got given. You're not going to have to draw another curve. Don't start drawing new quadratics. Try and edit it so it's like the one you've been given. Make it easy for yourself. Right, you have a look at the bottom one and work out how to make it back into the question that's been drawn for us. Okay, should we have a look together? So we've got 2x squared plus 5x plus 2. I don't want plus 2, I want minus 3. So I've got to take away 5 from both sides. When you take away 5 from the left side, you end up with minus 3, which is what we want. When you take away 5 from the right side, it goes from 0 to minus 5. So now I've got my two functions, I've got the curve, and I've got the line y equals minus 5. Draw that in, that's right down there, y equals minus 5. And then we can find our solutions. We have two negative ones this time. We have minus 2 exactly, and we have minus 0.5. Oops, nice ones to read off there. Minus 2 and minus 0.5. Okay, are we happy with how that works? So it's often a skill that gets glossed over a bit because it's a little kind of micro topic there, but I think it's really important to know how to edit those equations to make them like the one you've been given. All right, well done. Now we're going to look at drawing everything together. So everything from this session and the previous session, and we're going to throw in a few transformations just because we can. So these are really good grids. I really like these to try and to link together the whole topic of quadratics because it shows you what you can do. So we're going to focus on this middle bit that's been given to us. X minus 2 and x minus 5 equals 0. And from this information only, you can fill in the whole rest of the chart. I'm going to do this one with you and then give you a blank one to do yourself. So this is like my little recap of how to do all these parts. So let's have a look. I could choose any of these bits to do first. I think I'm going to go straight into doing the roots of my equation. So my roots up here, I know if it's in this format, my roots are going to be x equals 2 and x equals 5. I'm just flipping the sign. It's a nice simple equation. Straight away I could put that on my graph. If I know that x equals 2 and x equals 5, the roots on my graph are the x-intercepts, 2 and 5. So I know in a minute that it's going to go through there. Okay. From that, I can also get my original equation. So we look in the top left-hand corner here, equation in the form y equals ax squared plus bx plus c. So I want to get back from this root version to my original. And we can do that by expanding. X times x is x squared minus 5x minus 2x plus 10. Simplify it and we get, remember your y equals x squared minus 7x plus 10. Okay, so I've just expanded that to go back to my original equation. Now I could see if there's anything else I could put on my graph, because this plus 10, do you remember what that looks like on the graph? The y-intercept. Now I actually don't have the scale for that, mine only goes up to 4, but that does tell me it's not going to touch my axis on my little drawing, it's going to be really steep. So I'm just going to write that off to the side here so I remember when I come to draw it that the y-intercept is 10. Okay, super. Now we've got a few other bits to do. I've also got that down here actually. You see the bottom left hand corner, y-intercept is 10. And we always get that from that original equation. Now the next bit we've got to do is the completing the square, and that's this top right hand corner. You do that from the original equation. So I can't zoom in that much. Oops, sorry about that. We're going to use the original equation in the top left, x squared minus 7x plus 10. This is a bit of a recap from last session. I'm going to use fractions here. We halve that middle term, so we end up with x minus 7 over 2 in brackets squared. So that's my square. Now I've got to complete it. If I square that 7 over 2, 7 over 2 times 7 over 2 gives me 49 over 4. That's what I get. I want 10. Now I've got to try and work out how to get from 49 over 4 to 10. I'm going to make that a mixed number. So that is actually 12 and a quarter. So how do we get from 12 and a quarter to 10? We take away 2 and a quarter. Okay, so that is my completed the square form. X minus 7 over 2 squared minus 2 and a quarter. You could have that in decimal version, that's fine. From that, hopefully from last session, you've remembered we can find the turning point. So I'm now down here, that middle bottom box, coordinate of the turning point. Now, do you remember if the number's in the brackets, like that minus 7 over 2, we flip the sign, so it's just 7 over 2. The number outside the bracket, we keep the sign, minus 2 and a quarter. Okay, so that's just come from our completed square form, and we've got our turning point. Now let's look at our graph. Can we put that in? So we've got 7 over 2, that's 3.5 on the x-axis, and minus 2.25 on the y-axis. So that's going to be about there is my turning point. Okay. I've now got enough information to sketch my graph. We can see from that anyway that it's a positive parabola, a nice U shape, but we can also see from our original equation that x squared is positive, so I know that it's going to be a nice U shape. Remember, it's not going to cross the y-axis, so just draw it nice and steep, but still a curve. Because I'm on a stylus here, it's a bit tricky to get it, but make sure you go through that bottom x as well. Get that turning point in there. All right, well done. We're nearly there. That's all the stuff we've covered already, but we've got a few more little bits here. I've thrown in some transformations. So, the equation of the line of symmetry. Look at your graph, and hopefully you can see that it is symmetrical. All quadratic graphs will be symmetrical, and they'll all be symmetrical about the turning point. So if we draw a little mirror line down here, or line of symmetry, can you see it's symmetrical about that point? And that point is our turning point. So it all links in. Now we have to write that line as an equation. So an equation of the line of symmetry. It's going through the x-axis, so it's going to be an x equals, and it's going to be 3.5. You could leave that as a decimal. That comes from your turning point. Okay, 7/2 is 3.5, or you could write it as a fraction, either way. Can you see how that is? Your equation of the line of symmetry is x equals 3.5. Right, last bit. We're going to do a few transformations. So we need the coordinate of the turning point after the following transformations. Now a translation by vector minus 3, 4. Do you remember your vectors are just like coordinates? It's x before y. So that's what we're talking about. The minus 3 relates to the x-axis, or the x-coordinate, and the 4 relates to the y-coordinate. So minus 3 along the x-axis means that it goes left 3. So my coordinate of my turning point was 7/2, so 3.5. If it goes left 3, it's just going to be at 0.5. Happy with how we've done that? So it's just the x value, because it's that top one of my vector. The x value, we take away 3. Now our y-coordinate was minus 2.25, or minus 2.25. We've got to add 4. Okay, if we add 4, we end up on 1.75. I think I've got that right there. Yep, hopefully. Okay, so we've translated our turning point. If you look at the curve there, could we work out where it is? 0.5 and 1.75. So it would now be at 0.5 or 1.75. It would be up there somewhere. Okay, it has gone 3 left and it has gone 4 up. Okay, last bit. If we reflected our whole curve in the y-axis, where would the turning point now be? So you can look at that graph if you need to and imagine it flipping. Think about what coordinate's going to change and what coordinate's going to stay the same. So imagine the y-axis is the mirror, the curve flips over to the left-hand side. Our x value is now going to be minus 3.5, or minus 7/2. Our y value is not going to change. It's still going to be minus 2.25, or 2.25. Okay, so if you imagine that on the graph, I can't draw it on this graph particularly, but our graph will now be over here. Okay, flipped in the y-axis. The height doesn't change, it's just the x value has become negative. Okay, can you see how all of that links together? And you don't need to start in the middle. You could start from anywhere, any of those bits, and find the other relevant ones. And they'd all link in together. Okay? The next slide just has the solutions that I've gone through, but just in a neater format if you wanted to look and you were doing this in your own time. So those are the solutions that we've talked about. And here is one for you to have a go at. This time you're starting from the equation up in the top left-hand corner. It's slightly more challenging because you've got 2x squared and you've got to fill in all the rest. I'm going to give you 2 minutes for this. It might not be long enough to do it all, so start on the things you find tricky And remember, after this session, you can always go back, pause it, and take some more time over it. All right, 2 minutes, off you go. Just a reminder, you can always type in the chat box or the comment box if you've got any questions, and I'll get back to you as soon as I can. All right, just 30 more seconds. I reckon you can do one more block. Okay, I'm going to put answers up now. Well done for what you've done. If you don't want to look at the answers, then don't. Turn away for a minute. And remember, you can pause this later on and have some more time for it. Answers are now up on the screen. Remember, you can have the fraction equivalent. So if you need to think of the fraction equivalent for some of those, to check whether you're right. Any questions about those answers, just type in the chat box and I'll get back to you. All right, and we're going to move on. Fab. Well done. Really good work on that. Now, I'm not going to go through this extension now. This is one for you to have a go at after the session. But I'm just going to explain it because it's a little bit of a tricky task. You've got to match each of the graphs on the right to one of the statements on the left. Now, some of the statements might seem like they go with 3 or 4 different graphs. But there is only one possible graph and one possible number for each. So there's got to be only one graph for each statement and no duplicates. So for example, if one of the statements could be graphs 1, 2 and 3, but you know that the next statement could only be graph 3, it means graph 3 couldn't be for the first statement. Sounds a bit confusing, but it will make sense as you have a go, I'm sure. But if you just start listing the ones that it could be, you'll find the answers. All right, I'm going to leave you with that. Answers are coming up, so do avert your eyes if you don't want to see what's happening. Okay, I'll leave them there for a second for you to mark if you're watching this after the session. All right. Okay, well done on that today. That ends our quadratic session. So we've been doing lots on quadratic equations. I hope that's a really good recap for you. And if you're confident in all those skills, that puts you in really good stead for going into year 11 because so many questions are based on those. So well done for keeping up. You can download this full annotated version with the solutions from my website, mrskslightbulbmoments.wordpress.com. If you want any more practice questions, there's a few on quadratics there on Core Bit Maths. Next lesson will be next Monday the 15th at 5 p.m. on YouTube and Facebook. Just tune into my page or my channel at that time and you'll see the link. And next week we're going to be moving on to Pythagoras and trigonometry. just a quick recap of Pythagoras and then trigonometry, and we'll look at some trickier questions. All right, well done. See you next Monday.